Good morning. I'm going to take this class for hardware configuration, how the hardwares we are going to configure in the session. You can see now, I'm going to open a schematic manager. In this session, we can see that how the hardware we are going to configure, means hardware already configured in the last session, in the digital inputs and outputs, how we can install in the hardware configurations. Okay, first of all, we go for the schematic 400 station, click that one, go to hardware, because here already in the last session we created the CPU with this one. So now the hardware session, what we are going to see is, first normally in the rack, this is a rack. In this rack, first one is power supply, another one is CPU, next one is CP card. Okay, this is the normally this will be like this only. Next all are IO models. So you cannot insert IO models in the fourth slot, third slot, first slot like that. You have to mention in the fifth slot only. Okay, right click, insert any model you want, which digital input model you want, you can take that one. Because in the hardware configuration, first of all, in the rack means first is normally power supply, the next one is CPU, another one is CP card or any communication cards, and the third the fourth one is, that is your IO models. So now I am going to put any single models. Okay, so I want to give a single model. SM model is single model. In the single model, what and all is there? A card is there, AO card is there, DA card is there, DO card is there. So these are the signal models: analog input card, analog output card, DA card, DO card. Okay, so this is for the 400 stations. Okay, see, because this rack which is only for the 400 stations. Okay, so you want in the 300 station means you have to make a Profibus node. In the Profibus node you have to connect, because in this rack is mainly for the 400 station only. Okay, so I can get now the 400 model A16 into 13 bit. This is the resolution. 13 bit is nothing but it's a resolution of that one, 16 into 13 bit resolution. Okay, so this is one card, 400 card. Okay, in this card I can see, if I want to change the I make it a command, input one, just I'm making a command and check that address 512. This is start from 512. I can make it, plan to make it 256. Just I'm checking, but the thing is, it is default. We can make it 512. So because that is default, it will be the calculations. So now I can make it inputs. It's possible to change the address also, but as per the 400 stations, it is started from 512. Okay, inputs. You can see here which input you want. Analog input card means you have a 4 to 20 milliamps. You can see the options here. Minus 1 volt is there, 1 to 5 volt is there, plus minus 1 volt is there, because these are voltage. E means that is refers to a voltage. Okay, so this is the first channel, second channel, third channel, fourth channels. So in this card, how many channels is there? 16 channel input it is. Okay, so I can go up to this one. See, you can see up to 15. That means 0 to 15, 16 channel. Okay, I want to go this one by one. So I'm going here, right? You can see here we can select this channel into different. You can see unfair here. Either you want voltage, or you want to current or four-way transmitter, or you want current two-way transmitter. You have the difference now. Four-way transmitter. What is four-way transmitters? What is two-way transmitter? Actually, the two-way transmitter is nothing but loop powered. Loop powered means you will send a voltage from here and return that signal from that other cable. That is two only. You are using only two cable in this one. This is 4-wire transmitter. 4-wire transmitter is nothing but you have to provide separate supply and 2 cable that is separate for the signal. That total 4 cable, that is 4-wire. So you will get, if you select a 4-wire, so you have to give a supply as individual supply to this one separately. Okay, so this is either 4-wire you want. If you select a 4-wire, you are getting this 4 to 20 milliamps or 0 to 20 milliamps. Which one you want? If normally we are using 4 to 30 milliamps. You know, 4 to 30 milliamps. Why you are using 4 to 30 milliamps? Because that is dead zero. If any wire break is happened, we don't know. The indication will be it is showing they are always showing 0 to 30 milliamps, means it will show 0 only. If it is wire break happens, it is also showing the 0 only. So we cannot know. That's why dead zero we are saying that one 4 to 20 milliamps. So okay, normally we are using 4 to 20 milliamps in our system. Okay. This one category. So I don't want this channel. I don't want this channel. So okay. So I want to no need this channel. So what I do, I go put deactivated. So now this port will not be readable. Normally this one, why we will deactivate? Because no one should give connections here. It will not do any malfunctions. If it is not required, we can put a deactivate. But the thing is, every time we'll put whatever the channel here, we can put the same thing here, because if any problem happens during the running time, we cannot download the this one hardware configuration directly, because it will go to the swap mode. To avoid these things, normally initial itself we can configure all the ports, which one we are in the spare ports also we configure it with the which input you want, like that. So it is for the safety purpose. If any problem in the example, in problem happens in your running time, in the channel is not reading. Okay, channel having the problem or channel is getting damaged. Okay, so what we'll do, during the time I can switch this one to the next channel. Okay, that is easy for you. I can switch this one to the next channel. That is easy for you to avoid download, hardware download. Okay, so that time only you want to change the address only. What is the address for this one? You can change it in the our CPU itself. Okay, that no, sorry, we can see it is change it in the program itself. So program downloading is not a problem during the running of the plant, so it will not affect anything. Okay, so this hardware, don't want to touch the hardware, so you can already configure this example, this one. Okay, and then see here, you can see one difference here. These 2 channels, which channel you select first here, you cannot change here. See, whatever you select here, that only you can do here. In the first channel, what you are doing, because 2 channels it is parallelly connected. So if it is whatever channel you are selecting here, you have to configure that one only. Either it is deactivated condition, otherwise the same way you have to configure. Okay, but if you select here, example, I put a voltage. Okay, now you can see here everything here voltage only. Whatever you are doing here, it will come here. Alright, first itself you put a voltage only. So okay, so you cannot select anything here, the second channel. The first channel what you are doing now, same thing will follow by the second channel. Okay, but in this is second, this is separate. Same thing happen for the this fourth channel. Second channel, what is that is the third channel, what is following, same thing we can configure for the this channel also. Okay, did you understand? Okay, then this is one situation. Just I'll make it in the hardware. Now I'm going to install insert object. Now I'm going to install one AO card for your reference. Now I'm going to, in the signal mode only, I'm going to here and then check that AO card. Okay, now in this AO card only one card is there, so I'm opening that one. So now I'm going to give an address. Here also commands whatever you want. Here also you can change the name. Okay, analog output 1, which area you can select like that, no problem. Okay, here you can see the descriptions. Analog output model, AO8 channel, 13 bits resolutions, conversion time 430 microseconds, 1 to 5 volt, version 4 to 20 milliamps volt, 4 to 20 milliamps, because both it will be allowed. 300 microseconds, 0 to 10 volt, 0 to 20 milliamps. This is response time, conversion time. It will be 4 to 20 microseconds for the 1 to 5 volt and 300 microseconds for 0 to 10 volt or 0 to 20 milliamps. Okay, so you can see here this address. This also you can changeable, whatever you want you can change. The thing is, this will be clear for you. And then one more thing is here I can make it, this is your how many channels I told you, 8 channels, right? How I say 8 channel, here so let's say AO8, 8 is 8 channel, that is 13, the resolution is 13-bit resolutions. Okay, so here I can see up to 7 here because 0 to 7, so 8 channels are there. Okay, so here also I can change whatever you want, the same thing, either voltage or current. If it is current, you can select here 4 to 20 milliamps or 0 to 20 milliamps. Okay, here you can see the same thing, but this one, no, first channel is like this, second channel it will not follow because it will be individual, it will be all individual. Okay, did you get a clearance? Okay, so now analog output is finished. Okay, I give a finished. Next I'm going to, what is that, insert object, some model here, DA input. Just I'm checking which input, it is a 24 volt or 230 volt or 130 to 230 volt, whatever is there, it will be here. So okay, I will check a 32 channel DC 24 volt. Okay, this 32 DA 32 means 32 channel DC 24 volt. How much voltage is 24 volt? So I'm opening here. Here I can put a digital input just for checking, show as this one purpose. Okay, and then address you can see here, whatever address you want, you can make it 1. I make it, before its default is 0 because first input. If you want make it 1 you can make it, no problem, 1, because it is, why it is not accepting, because 0 to 3 already is there, so you have to make 4. See, now 4 means 4 to 7 it will be there. See, you can see now, before 0 to 3 was there, now it, because how much inputs I told you, it is 32 bit. Okay, so 32 bit, this I told you na, 32 bit, this 24 volt. Okay, so that's why. And then here it's showing, see, rack, what rack it is, rack 0. Okay, which model, single model is connected in the S7, that is 7th slot number is 7, so that's why it's showing. Okay, so now I make it 0, now it will be 0 to 3, showing 0 to 3 because 0, 0.0, 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, like that it will go to up to 3.0 to 3.7. Okay, that is 32 bits will be there. Clear? Now I'm going to take a digital output, insert object, opening, it's taking time, Devo. See, here also I am taking one DC 24 volt, how many amps, because it is 2 amps or 3 amps, like that is there now output, so I am taking the 2 amps output. This is how many channels, 16 channel, how many volt, 24 volt, how much amps, 2 amps per channel. Okay, so here I make it as digital output. Okay, so here you can see the 16 channel, this 24 volt in amps. Now you are seeing, before you seeing that's 7th address, now it is 8th rack number, slot number 8, rack number 0, rack number 0. Okay, so address I can change now, before 0 to 1, because why it is 0 to 1, it is 16 bit, so 0.0 to 0.7 and 1.0 to 1.7. So I can make it, this is 1, it will not accept because already is there, so I can make it 2 it will accept. I make it 2, see the 2 will accept. The address you entered is not valid. Okay, why it is not valid, just check. Three. Okay, because this one is taking like this, we'll see. Now, okay, because this will be in that already. If I put a, we'll see, I put here, now I make it, see how much it is coming, 0 to 1, only it is taking. After that is 4 to 5 it is coming. So that means that is not taking by that one. So that's why now 4 to 5. Okay. Now same thing I putting. See that one. It is taking as a 32 one every 4 bytes only it is taking. So that's why now it's saying see 8 to 9. See what happened here. It's 4 to 5. One slot is taking 32 byte, automatically it is taking 32 bit. Okay, so 4 to 5 already 16 bit is occupied, and then 2 bytes it is not taken by it is not automatically, it is already configured by the system itself, so it's not taking that other address 4 5. I cannot give 6 7 is default, it is there, so it is occupied by this slot. So for this digital output, it's total taking 32 bits, but the address it's showing is 4 and 5 16 bits only. Okay, you got my point. That's why it's 6 and 7 is not coming. Before I told, you know, by 2 I put, it is not coming, but if I put 4 it will come, right? Okay, so now you are clear with this configuration. So after finishing this one, you can make it save and compile. If there is no error, it will any error it will show error even the save and compile. Normal save is only for saving that program what you did. Save and compile is nothing but it will show the error also. Okay, once it is finished, you can establish a connection with the CPU and download to module and upload to programming device. Okay, so now we seen that configuration of IO modules with the 400 PLC. So next topic we'll see the configuration of IO modules with a 300 PLC, say some 400 PLC with 300 modules. Okay, that we'll see in the next topic. Thank you very much.